Hi everybody. This is just a sample of how to stimulate a program in XILINX. Simple using Verilog. So I go with this. I've downloaded this 13.2 version XILINX. I open this. I will get a window of the tip of the day. This is actually which says about about the XILINX or something else which is which might be useful. Let me ignore it first. Now this program I have done already, so I'll just go for the new project. So this is how I start. I start with a new project. I give it a name. Give your own name. You can give your name or any folder in which you will have the projects. So I give for example, I just give just project. That sounds better. So it actually allocates the directory automatically. You need not specify anything. So if your C is full, you change your directory. Okay, if your C is like it cannot take many folders. If you have less space, change your folder to E. Since I've already done before to change this E. I have done it before. It was actually C. I just changed to E, and this is in HDL always. So I don't need to go for the others right now. Now check for this. You have family Spartan 3, device XE3S 400, package TQ144, speed -4. If it is Spartan 3E or something like that, you'll have Spartan 3A, 3E and all. For that I'll have -5. It varies according to the FPGA kit. Now this is all according to my FPGA kit. In that chip, in that small black color chip, it will be written. So accordingly I have to change this, and it's mostly of this kind. And for the synthesis tool, simulator and preferred language, you got to have this by default. So synthesis tool is like XST, VHDL or bar Verilog. Simulator is ISIM, VHDL bar Verilog. And then you have Verilog. So I'm not doing VHDL, I'm doing Verilog actually. That's quite simple, and that's all. VHDL 93, it allocates itself. So this, after I click next, whatever I have done right now in that project settings, I have it summarized here. So in case if you have done anything wrong, you can just check it out here. If you have done anything wrong, you just go back and rectify it, and again go with the next and finish. Now I'm with the finish. Over. Now it clearly shows. Now it's already by default I have this implementation clicked. Okay. Now under my project I have another file being created. Now that's my project file actually. So I have this created file. Now I need to add source. So I right click, new source, and I go with Verilog module because I'm doing with the Verilog language. In that whatever operation I'm supposed to do, I'll just have it named. For example, I do an OR, simple OR operation. I'll have it OR. So I go for a simple OR module. So I'll have OR. I cannot have just OR because my directory file will have something OR and it will have it overwritten. So I'll have OR1. Okay, the OR is a keyword, so I shouldn't use it in my file name. So it will overwrite and would not, and it won't show the correct result. It might show an error. It might throw an error. So I'll have OR1. Add to project. By default it has to be ticked. If not, just tick it out, and then click that, and then go for the next. In case you want to provide the inputs here itself, port names A, B or something like that, you can provide it here, or else you can provide it in the program. I go for an easier way, so I'll have this A and B, which are the inputs, and I'll have my out as my output. Okay, I go for the next. See the Verilog module, the language I use, and this is summarized part wherein I gave A, B as my inputs and out as my output pins. And I go for finish. Now you would have got a program already being written, because I had specified, right, input and output, so it has already aligned itself. Now I must specify my operation, so my keyword is OR, so that is what I'm supposed to do. Now OR, always my output will come first and my inputs will go the next. So I can have A comma B or B comma B, A, that doesn't matter. And I close and I end with a semicolon always. Okay, and I end module, it's alright. Now then my next step is to create a text bench. It's like TB, okay? For this I have to create another source file. This I'll have new source. I'll go for Verilog text fixture because I'm going with the text bench source. So I'll have again OR operation 1. I shouldn't give the same name in order not to get confused with any other file, so I go with underscore TB text bench. I'll have this ticked. Next, finish, summarized. So again, if you have any problem, if you find something wrong you have done, you go back and rectify it, or else go for the finish. Yeah, now this is the text bench which I have been talking about. This, why do I need a test bench is a good question, because so we use test bench in order to give inputs. So I'll have A, B as 0. Let me give all the all the 4 type of inputs. So it's like 2 bits, so it's 0, 0, 0, 1 and 1, 0. I'll have it copied, and this is all the comment lines. These are the comment lines, so I need not bother about that. I'll have all the 4 things. Now this is 0, 0 and this is 0, 1 and this is 1, 0 and this is 1, 1. Now you might be wondering what this 100 is. It's a delay. It's a delay for the next inputs to be executed. I mean for the next inputs to go and have my output executed. Now your text bench is ready, your program is ready, you need to save all. Okay, pertaining like saving my program as well as my text bench TB file is saved. Now I am supposed to execute it. How do I execute it? Now it is in always by default is in implementation. Now I go for stimulation and I click this. So when I click the last source file which have been used, the test bench file, I'll get down I get iSim simulator. In that I get what I'm getting is behavioral check syntax. So I'm going to compile it by just double clicking it, and I get a green tick, which is a very good sign because you don't have a syntax error, but it doesn't show a logical error. It might show in the graph if you have. So wait, now I need to run it over. I click that, double click, and I have this graph. Now you can clearly see for the OR operation, now A, B is my value. Wait until I zoom in because it's in nanoseconds, so I need to zoom in. So I just zoomed in, and for A equal to 1 and B equal to 1 I have 1, so that's my OR. Now for what 0, 0, 0, 0, 1 it has to be 1, 0, 1 it's 1. Okay, and for 1, 1 it is for 1 0 it is 1, and then if it is 1 1 1 1 it is 1. See, my output file is at the beginning and my inputs are A and B, which is down. And then if you want to look onto the schematic diagram, the block diagram of this might be helpful. Wait, I need to go for tools. Where do I find tools here? Wait a sec. I can close this. Yes, because that's the graph part. Now this is a program and the test bench file coding part. I go for tool, schematic viewer, RTL, register transistor logic. Now would you like to run necessary process to create this data? So I need the RTL, the register transistor logic, the block diagram. So I just clicked OK. It shows a running synthesis. It's loading. It's running. So and then you will have start with the Explorer wizard. You click on this. By default you go with that. OK. Okay, and then you have add. You click on add. You're going to add this, create schematic, and you got it. Now this is a simple OR, so I just got it. Now if I double click, I might get what's important, what my inputs are, what have they given. Now I'll just zoom in and zoom out, or zoom and see. My inputs are A, B, and I have my inputs as 1 and 0. So if it's 1 and 0, my output is 1, right? Wait, OR operation. You're having this is, I think, I don't know what does it say. It says 1 0 and 0, right? Input 1 and input 0. If that's the case, I have to have 1. Okay, I'll just see the graph. If it's 1 0, what happens? Okay, I can zoom in. That's why I get the same value. See, that's how it comes. It's not 0. Yeah, this is 1 0. My output is 1. And shouldn't I get the same? This must be, I'm reading out wrong. It must be like 1 1. It must be. No other go. It has to be 0 0, and so it's 0. Wait, let me check out here.